Hi, welcome to the notes on 4-4, Solving Nonlinear Systems. In the past, you've learned to solve systems of linear equations using three methods. You've learned how to solve them by graphing, substitution, which also includes the equal values method there that some of you have learned, and elimination. That was when we had two lines and we were looking for the intersection points. So we learned how to do a couple algebraic methods and then the graphing method. Today we're going to solve some systems algebraically, except they're not going to both be lines. When we start out on letter A here, you see that we have y equals 1/2 x squared plus 1. That's going to be a parabola. Right? We know that because it's got the second degree there. So since it's x is to the second power, we know it's quadratic. And on the bottom we have y equals 2x minus 1, which is just going to be a straight line. So that one's going to be linear. If you think about a parabola and a line, they could intersect 0 times. They could intersect, at 1 point, or they could also intersect at 2 points. So just looking at these equations, it might be hard to tell. So let's go ahead and solve this to figure out what the solution is going to be. Since these are both equal to y, we'll use that substitution or equal values method and set the two equations equal to each other, right? Because if y equals 1/2 x squared plus 1 and y equals 2x minus 1, then we know these two expressions have to equal each other. So we'll take it here and set it up. 1/2 x squared plus 1 is going to equal 2x minus 1. Next thing we'll do here to solve it, because it's quadratic, we're going to just set it equal to 0. We'll subtract our 2x and add our 1 to each side here. So we should have 1/2 x squared minus 2x plus 2 equals 0. So we've set it equal to 0. Let's get rid of that fraction here. Remember, we can multiply by a number that's divisible by 2, and to help us get rid of that there, in this case, it'll clean it up and make it a little bit easier for us to factor. When we distribute that 2 through, we should end up with x squared minus 4x plus 4 equals 0. Now that's an easy one to factor. That's a perfect square trinomial. We should end up with x minus 2 times x minus 2. And to solve it, we'll take one of those, set it equal to 0, solve, and we'll get x equals 2. Now we're not completely finished yet. Remember, this is a system of equations, and since we're looking for those intersection points, we need to find the y-coordinate as well. So we're going to take that value of 2 that we got for x, and we're going to plug it into one of the functions. I'm going to plug into the bottom one just because it looks easier to work with. We've got y is equal to 2, and now instead of x, we're plugging in the 2 and then minus 1. So our y value should be 4 minus 1, which is equal to 3. So we have that corresponding y value. Remember, this isn't a point on the graph, so we'll write it right now as an ordered pair, the point 2, 3. Now I already have the graph prepared here. I'm going to flip over to my graphing calculator so that you can see as we check our work. Okay, so you'll see I already have it typed in up here at the top. Y equals 1/2 x squared plus 1 and y equals 2x minus 1. When we look at the graph, you'll see we have our parabola here. Goes around like this. And then we've got our line here. And you'll see there that they do intersect at the point 2, 3. So that is their intersection point right there. All right, let's head back to our lesson here. And let's go on to the second one. Now the second one you've got here, you've got y equals negative 3x plus 5 and y equals negative 3x minus 1. Now these are actually both going to be lines, right, because they are both linear. And you'll notice here they have the same slope but different y-intercepts. So if we take this and we use our equal values or substitution method here and set this part of the equation equal to itself, or I'm sorry, equal to each other, we have negative 3x plus 5 equals negative 3x minus 1. If we go to combine our x's together, we're going to end up with 5 is equal to negative 1, which is a false statement. And that means there that we would have no solutions. Now, no solutions when we're solving algebraically means that the graphs do not intersect. All right, so no solutions means the graphs do not intersect. So let's look real quick here and just to make sure that we're getting that. Go in here. I already have these pre-typed in, make this a little bit faster and easier. So if you look here, you see that we do have parallel lines here. These two lines will not intersect each other. So they'll go on and on forever, never intersect. So therefore we have no solutions. All right, back to the lesson here. Let's look at problem C. It says, how could I use a similar strategy to solve y equals x squared and y equals x plus 2? Well, again, now we have another parabola and a line. Since they're both, again, set equal to y, you could even take this video now, pause it, try to work through it, and see if you can get the answer. Then you can fast forward through what I do and see if it matches. If not, just rewind it, watch, and see what I do that you didn't do. All right, I'm going to take it here. I'm going to set x squared equal to x plus 2. We'll set it equal to 0 now by subtracting x and 2. So we have x squared minus x minus 2 equals 0. We'll factor our trinomial. That should end up being x minus 2 and x plus 1. Once we set those equal to 0 and use our zero product property, we'll get that x equals 2 and x equals negative 1. Now remember, our original problem up here has x's and y's, so we have to go back and find our y values. Let's take each of them and plug them in to figure out what the corresponding y value would be. So if I say here y is equal to, instead of x squared, I'm going to put in 2 squared. We'll see that that y would be 4. So we're talking about the point 2, 4. For our other point there, negative 1. And you can plug it into either of them. It shouldn't matter. But we'll take it here and we'll plug it into the same one. We have y is equal to negative 1 squared. Negative 1 squared is 1. So we now have the point negative 1, 1. Now to check our work here, to make sure that, we don't end up with any extraneous solutions or anything here, let's take it and graph that one as well. So that one we had y equals x squared and y equals x plus 2. We graph it, and you'll see here that it looks like they intersect at our point negative 1, 1, and our other intersection at the point 2, 4. So if you got that, good job. We know that those are correct. All right. Make sure if you have any questions on this first part that you mark it down. We're going to go ahead and move on to the next part. Next one, we have now consider the system x squared plus y squared equals 25 and y equals x squared minus 13. So if you think back here to earlier in the year when we did problems that had x squared plus y squared equal 25, okay, this is the equation of a circle. And then we have another parabola there. Whoops, spelled it wrong. There we go. So what are our two equations? We just answered that. One's a circle, one's a parabola. How many solutions could we get? Let's think about it here. if you've got a circle, that parabola could not intersect it at all. It could go through, touch it once. It could go through and touch it twice. Right? It could go inside and bounce out. It could go through and touch it 3 times, or even 4 times. So you've got the possibility of 0 solutions, 1 solution, 2 solutions, 3 solutions, or 4. Let's look at how to solve it here. Because we have x squared plus y squared equals 25, and then we've got our y equals x squared minus 13, we could always take, what y equals and plug it in for the y. However, when you see this, if we do x squared plus this quantity of x squared minus 13 all squared, okay, and we say that equals 25, think about if you were to take the quantity of x squared minus 13 and multiply it out, x squared times x squared is going to give us x to the 4th. We're going to start getting some pretty complex polynomials that we're going to have to work with. So instead of doing that, what I'm going to suggest to you is let's take our y equals x squared minus 13, and let's go ahead and add 13 to each side. And what we're going to end up with now is going to be y plus 13 equals x squared. The thing that's cool about this here is, you see x squared right here. We have an x squared in the circle of our equation, so if x squared is really the same thing as y plus 13, let's take this y plus 13 and substitute it in for our x squared. So we'll do that down below here. We're going to take it, we now have y plus 13 plus our y squared equals 25. This is going to be a little bit more manageable for us to solve and get all the way through it here. Not that the other way can't be solved, but this just might be a little bit more efficient for us. I'm going to go ahead and put this into standard form. Y squared plus y plus 13 equals 25. Let's subtract 25 from each side. Now we have y squared plus y minus 12 is equal to 0. We can factor this. Should end up with y plus 4 and y minus 3 equals 0. So when we do each of those, y is going to equal negative 4, and y is going to equal 3. So we have 2 different values for our y's. So make sure you take note of those. We're going to take that and we're going to plug them into our equations to find the values of x. So the first one here, if I take negative 4, and we're going to plug it in for our y, I'll plug it into our less complex equation here, the bottom one, the parabola there. I think that'll be easier to solve. So we're going to say, instead of y equals x squared minus 13, we're going to replace it with this negative 4 first. So we got negative 4 equals x squared minus 13. We add 13 to each side. So 9 equals x squared. When we take the square root of each side there, we'll get the absolute value of x equals 3, which means that x has to equal positive or negative 3. What's this mean for us here? Well, that means when our y is negative 4, our x value could be 3. So we have the point 3, negative 4. Or our x value could be negative 3. So that kind of gives us 2 solutions right there. When we take our other value for y, when it equals 3, and we plug it in, we'll say 3 is equal to x squared minus 13. We'll add our 13 to each side. Now we've got 16 equals x squared, and again, when we take the square root of each side, we're going to get the absolute value of x. This time it equals 4. So we know that x is going to equal positive or negative 4. So when y is 3, our x could be 4, or it could be negative 4. So when we were talking about what are the possible solutions that we could have, okay, we're looking at this possibility where there were 4 solutions. To check it, get out our handy dandy graphing calculator here. And when we graph, you'll see, and mine's not very circular, let's make it more like a circle. This is what you'll see here. So you've got your parabola here going through, and it's intersecting at negative 4, 3, negative 3, negative 4, positive 3, negative 4, and all the way up here at 4, 3. If you got that, good job. All right, I think we're going to bring this one to a close here. I know there's one more problem for you to do. This is just a linear system of equations that I'm going to allow you to work on and see if you can solve it.